Right. Good morning, boys and girls. Good morning, colleagues. My name is Mr. Mpahama. Today we are going to look at trig equations as well as trigonometric functions. But of course, first of all, we are going to start with the trig equation, which is of course is very important part in trigonometry. Right. Of course, when you talk of the equations, you remember very well that it means where you're going to solve for x or you solve for theta. It is very important. You remember under cubic equations, you remember under quadratic equations as well. Now, under trig equation, what is it that is very important here is, you remember now you need to know how to solve the equations, because there are two parts here that you need to know. You need to know how to find the value of theta, and then the second one also, you need to find the general solutions for them. For that equation is very important. Right now, let us start first with what? Let us start first with the equation. If, say, for an example, now we have what? We have sine theta there is equals to 0,5. Of course, boys and girls, will agree with me that when you solve this type of equations now, the cast here is very important. It is very important to remember whatever that is happening now. You remember in the first quadrant, they are all positive. Then in the second quadrant, it's only sign positive, and then the tangent in the third. And now in the fourth quadrant is what? Is cos. Why am I bringing this? It's because it is very important to remember that a sine is positive in two quadrants, which is what? Which is the first quadrant as well as the second quadrant. The same applies with the tangent here. Tangent is positive in the first quadrant as well as in the third. It means sine, when you solve the equation, I'm expecting you to give me two solutions for that one, in the first quadrant as well as in the second quadrant for sine, and then for tangent in the first quadrant as well as the third quadrant, and also for cos in the first quadrant as well as what? As well as in the fourth quadrant. Right. Remember now, most of the time here I'm referring only if sine is positive, if cos is positive, and also if the tangent is positive. Now, but what's going to happen now if we have the negative now? If the ratio now is negative, what's going to happen? Of course, you are still going to get this two answers for sine if the ratio is negative, and then the two answers for cos if the ratio is negative, and then the two answers for tangent if the ratio is negative. Remember, here they are all positive. But now, in the second quadrant, we said it's only sine positive. It means we have a negative cos, we have a negative tangent, right? Right. In the third quadrant, what do you know? What I know is that tangent is positive in this quadrant, and therefore what? Then cos is going to be negative, and also sine also is going to be negative. Of course, I can see now within these two quadrants, cos is negative in two quadrants, right? Which is the second quadrant as well as the what? As well as the third quadrant, right? Now, the last one here, what we know is cos in the fourth quadrant is what? Cos in the fourth quadrant is positive. Therefore, if cos is positive in the fourth quadrant, then we have what? We have a negative sine and also a negative tangent. Then also you can see now sine is negative in two quadrant, and tan also negative in two quadrant. The boys and girls, is very important to remember when you solve the trig equations, it's very important to check if the restriction, if the interval is not given. Now must remember now, if you're working from 0 to 360, for sine, if the ratio is positive, I'm expecting to get two answers. But if the ratio is also negative, I'm expecting to get what? The two answers. It's very important, right? Now, let me start with the one where the ratio is positive, right? Let me now start with the one where the ratio is positive. Now, say sine theta here is equals to what? Is equals to 0,5. Right. Now, if sine theta is equals to 0,5, what is it that you are going to do here? Of course, it's very important. The first thing that you must do is to determine the general solutions, right? Now, what is it? Is determine the reference angle first. Of course, what is the reference angle? The reference angle there, that will be what? The inverse of sine what? 0,5. Of course, I think you can use your calculator here to get the answer there. What is the inverse of sine 0,5? 0,5, remember, is the same as 1 divided by what? 1 divided by 2. Right, can you check that one quickly? Yes, that is what? That is 30 degrees, right? That is 30 degrees there. It means sine theta here is equals to 0,5. Then the reference angle there, that is 30 degrees. Now, boys and girls, it's very important to remember this one. Now, the reference angle that we are talking about here, it is in the first quadrant. Why are we saying in the first quadrant? Because you see that most of the time, this angle that you're going to get here, it will be what? It will be less than what? Less than 90 degrees, right? Now, I'm happy now. I have the reference angle, which is what? Which is 30 degrees. Now, let me now respond to the question now. The question said, I must solve for theta. I must find the value of theta. Now, what is the value of theta now? I say, therefore, theta here is equals to. Now, before I write down the solution, it's very important now to go back to the ratio. Now, I check the ratio. Is the ratio positive or negative? Now, if the ratio is positive, now I go back to the side. In which quadrant here, it's sign positive. Now, remember now, sign is positive in the first quadrant, also in the second quadrant there. Then it means if it's in the first quadrant, the answer that you're going to get here, it will be what? It will be less than what? Less than 90. Of course, that is our reference angle there. Then it means we say, therefore, theta there is equals to what? Is equals to 30 degrees. Is that correct? Yes. Now, the second one now, like I said, we must have two answers for this. Why? Because sign is positive in two quadrant. Then the second one will be what? Therefore, the theta here is equals to what? Now, in the second quadrant, we know that these angles here, they are more than 90, but less than what? But less than 180 degrees. It means this one here, it will be 90 degrees, and this one here will be 180 degrees. Now, the angle that we're talking about here, it's in this quadrant here. Right now, how do I determine this one? You remember when we apply the reduction, we say this is 180 degrees, this is 180 degrees minus, right? That's exactly what you're going to do here. We say, therefore, here, theta is equals to 180 degrees minus. What is it that you're going to subtract here? Then we subtract the reference angle there, which is what? Which is 30 degrees. Therefore, what is 180 degrees minus 30? It is 150 degrees. Now, can you see now? I have two answers now. It means sine theta there, theta can be 30 degrees. Now, if I have sine of 30 degrees, it will give me 0,5. If I have sine of 150 degrees, it will also give me what? It will also give me 0,5. Right? Now, it's very important each and every time, make sure that if you are working in the interval 0 degrees to what? To 360 degrees. Now, I'm expecting you to give what? To give us the two solutions for theta. The one in the first quadrant and the one in the second quadrant. The reason being, sign is positive in the first quadrant as well as the second quadrant. Right now, what's going to happen now if it is negative? What's going to happen? Right now, let us take now this one as a second example now to say, okay, if now sine theta is equals to negative 0,5. If now we say sine theta is equals to negative 0,5, what is it that you are going to do in this case? Yes, we are still going to do the same thing. The first thing that we need to have there is to have what? The reference angle. It's very important. We are not yet solving for theta, right? We are not yet solving for theta. Then we have the reference angle there. The reference angle there, that will be the inverse of sine what? Now, this is very important. Remember earlier on, I said now, the angle that you are working on under the reference angle, it is in the first quadrant. You should remember well. Right. Now, it means now, when you look here, the x on the first quadrant, the x there, they are positive, and also y there, they are positive. It means now we must make our ratio what? We must make our ratio positive. When you find the reference angle, remember, always make sure that you make what? You make the ratio positive, right? Now we have the ratio positive. Now we can now say, what is the inverse of sine 0,5? Then, of course, you'll agree with me now. The answer there will be what? Will be 30 degrees. Is that correct? Yes, that is the inverse of sine 0,5. That is 30 degrees, right? Now, what is the next step from here now? Remember now, this is not the value of theta. No, right? Now we are solving for theta. Now we say, okay, therefore, what is the value of theta now? Right, before we write down the answer, what is it that we must do? First, we go back to what? To the ratio. Now we check, is our ratio positive or negative? Is our ratio negative or positive? Of course, the ratio here is what? It's negative. We have negative 0,5. Right now we go back to the cast now to say, okay, in which quadrant is sine negative? In which quadrant is sine negative? Now, of course, now we can see the first sine is positive and the second quadrant also sine is positive, right? Now, in the third quadrant, you remember now, we have a negative sign there. It means sine is negative in the third quadrant. Now, what do you know in there? When you apply the reduction now, we say the angle in the third quadrant is the 180 plus, right? It means for us to have the value of theta here, we will now say theta is equals to 180 degrees plus what? Plus the reference angle. What is the value of the reference angle there? That is 30 degrees, right? Now we can now solve this one to say, okay, 180 degrees plus 30 degrees, then the answer there will be what? The answer there will be 210 degrees. Can you see this one? Yes, but now remember, sine is positive in two quadrants and also sine is negative in two quadrants, right? We need to have another one here where now we are going to say now, therefore, theta also is equals to what? We check again. We said sine is negative in the third quadrant, and also when I look under the fourth quadrant here, then sine is still what? Sine is still negative there. Therefore, now, in the third quadrant, then you remember now we have the fourth quadrant, we have 360 degrees minus. Then it means this one now we are going to say theta is equals to 360 degrees minus what? The reference angle there, which is what? Which is 30 degrees. Then now we say, okay, 360 degrees minus 30 degrees, then the answer there is 300 and what? 330 degrees. Right now, boys and girls, this part here is very important. I always say, if you know how to solve the tricky equations, then to determine the general solutions, then it's going to be easy for you to have that one. Right now, let me now take this one as well to say, okay, now we are happy with the sign. We know that sine is positive in the first quadrant as well as the second quadrant, but also negative in the what? Negative in the third as well as the fourth quadrant. Right now, let us now look at cos. Right now, we have cos of what? We have cos theta there is equals to what? Cos theta there is equals to 1 divided by square root of 3. Right now, can you now say in 2 minutes? Can you just work this one out, see if you'll have the solution? Then I'm going to discuss this one with you after the 2 minutes. Okay. Right. Thank you very much. Thank you. Right. Let us go through this one to see what is it that you have. Right. Of course, the first thing that we need to do, like we did with the previous examples, to say, okay, first of all, we need to have what? We need to have the reference angle here. Right. How do you determine the reference angle? Of course, that will be the inverse of cos 1 divided by square root of 3. Remember always, this must be positive because now we have this in what? In the first quadrant. Right now, what is it that you're going to do now? Now we say, okay, that is shift there, and now we have cos, right? Of course, what is it that we have? 1 divided by what? Divided by square root of 3 there. And now we say, okay, then it says now the answer there is what? It says now the answer there is 54, 54,7. Right, of course, we can round it off to what? To 2 decimal place. Then it says the answer there is, it's 54,774 degrees. That is 54,7 degrees. Right, now, once you are done with the reference angle, of course, you remember now, the next step now will be for you to determine what? To determine the size of theta. Now we say, therefore, here, theta is equals to what? We check now. The ratio here is positive. Therefore, cos is positive. Cos is positive in the fourth quadrant as well as the first quadrant there. Therefore, it means here we are going to have 54,74 degrees. Of course, the other one there, we are going to have what? The other one there, we are going to have, therefore, here theta is equals to what? 54,7 degrees. Of course, we need to start first with 360 because now it is in the fourth quadrant. 360 degrees minus 54,74. Right, of course, now we will have the answer there. We take now 360 degrees minus 54,74. Then the answer there is what? The answer there is 305,26 degrees. 305,26 degrees. Right. Good people, like I indicated, it's very important to know how to solve this, the trig equation. Of course, you will see now when you go to the general solutions, it's not that difficult. No, you will see that it's not that difficult. Thank you very much. Right, now, let us look at this question here. That was November 2008. Question number 6 there. It says now 6.1.2. Determine the general solutions for tan x minus 1 divided by 2 is equals to negative 3. And now correct to 1 decimal place. Very important. Right, now, what is it that you are going to do first here? What is it that you are going to do first? Of course, what we must do first here is we need to solve the equations first. Let us now solve the equation first to say, okay, we are given that tan x minus 1 divided by 2 is equals to negative 3. Tan x minus 1 divided by 2 here is equals to negative 3. Right, this is the equation that is given here. Right, let us try to solve this equation. What is it that you are going to do first? That is a cross multiplication because we have a term on this side and a term on the other side. This is the same as divided by 1. Of course, 2 times minus 3, that will be minus 6, right? And now what do we have on this side? We have a tan x minus 1. Right, so far so good. But what is it that we are looking for? On the left-hand side, I want only tan x. Then the number can now move on the other side. That's good. Right, let us now do that. That is tan x here is equals to, this is negative on this side. We agree? Yes. When we move it to the next side, now it's going to be positive. Then it means now we are going to have minus 6 plus 1, which is equals to what? Minus 6 plus 1 is equals to minus 5. Therefore, here tan x is equals to a negative 5, right? Now it means now the ratio here is minus 5. Of course, it's very, very interesting question, this one. Very, very interesting. Right, now, what is the next step from here? Of course, we need to have what? We need to have the reference angle, right? We need to have the reference angle. Then our reference angle there is equals to, of course, that is the inverse of what? Inverse of positive 5. Why is it supposed to be positive 5? Because like I said, this one here, the reference angle is in the first quadrant. In the first quadrant, x is positive and y is also positive. Right, now, once we have this one now, we can now say, okay, we have shift there, and now tan, and then we have positive 5, and then what is the answer there? It says now the answer there is 78,69. The answer there is 78,69. Right. The answer there is 78. Let me check. It's very important to check the calculator if it's in the degree mode or radian. Yes, of course, it's in the degree mode. It's very, very important, right? Now, that is the shift that is turned there, and now positive 5. Then we have what? 78,69 degrees. Good. Now we are happy. Now we have the reference angle, but we are still looking for the value of x. How do I determine the value of x? It is very, very important now. It is very, very important part. Now we say, therefore, x is equals to what? Before now you can determine the value of x, you need to go back to the ratio. You check the sign of the ratio there. Is it positive or negative? If it's negative, now you say, okay, in which quadrant is tangent negative? Of course, tangent is negative in the second quadrant, also negative in the third quadrant, right? What is it that you must do now? Of course, what I must do now is to say, okay, in the second quadrant, we have 180 degrees minus the reference angle there, which is 78,69, right? Of course, now when I solve this one now, we say, okay, 180 degrees minus 78,69, then what is the answer there? Of course, the answer then will be 101,31 degrees, right? That is the first solutions that we have, which is, of course, is in the second quadrant, right? The other one, which is now is in the fourth quadrant, that will be x is equals to 360 degrees minus the reference angle, which is 78,69 degrees. Now we check, now we say, okay, 360 degrees minus 78,69, then the answer that we have is what? We have 281,31. Right, now we have solved the equation now. But have you answered the question yet? No. The question said we must determine the general solution. We must determine the general solutions for this equation here. Right now, what do you do when you determine the general solutions? Of course, it is very, very important here. Right now, let us look at this one, right? What do you know about the tangent? Right, we know that the period of the tangent there is equals to 180 degrees. It's very important to this part. But what about the sine as well as cos? Now the period for sine and cos is what? Is 360 degrees. Right, this part here is very, very important. Once you have solved the equation, right, what you can do now, when you determine the general solutions, now in this part that we are having 180 degrees minus 78,69, then you add the period of the tangent, which is k times what? 180 degrees, right? You add k times 180 degrees. Of course, you must also indicate that k is an element of what? K is an element of the integers. Right now, of course, the next step now, you can now simplify to say 180 degrees minus 78,69. Of course, the answer is 101,31 degrees. And plus what? Plus k times 180 degrees. It is very, very important. Right now, for the first part there, you have written now your answer in a general solution now. Now the second one, we do the same on this one here. 360 degrees minus 78,69. Of course, we must add k times what? 180. What is this 180? That is the period of what? That is the period of the tangent. Please don't forget to indicate that k is the elements of the integers, right? Now, after you've simplified this one, that is 281,31, and now you do the same here. We still have k times 180, k times 180 degrees. Right, once now you are at this stage now, it means now you have solved the equations. Now you have both solutions now. For tan x minus 1 divided by 2 is equals to what? Is equals to a negative 3. Right. It is very important in these questions. Very, very important. Good people, remember, once you can master the part of solving the equation, right, of course, the general solution one, you remember the period. What is the period of sine? 360 degrees. What is the period of cos? 360 degrees. And now, what is the period of the tangent? That is 180 degrees. Right, I think now you have the general solutions here. Of course, even if we can just go back a little bit to the one that we started on with this earlier on. Right, where we have sine theta is equals to 0, 5, then we have the reference angle here. Right, if the question was I must determine the general solutions, of course, because now I have solved the equation. What is important is now I need to remember the period of sine. If the period of sine is 360, then I just say this one will be plus k times what? Time is the period. What is the period? That is 300 and 360. It is very, very important. Because that's how you determine the general solutions. Very, very important. Of course, there are a lot of marks under the general solutions. Right. Is there any question? I think now we are fine with this one. If you have any questions, please feel free to ask those questions so that at least we can get a clarity under the general solutions. Right. Now, let us now go to the next question here. The one that we did was November 2008. Let us now look at November 2010. November 2010, 10.3. It says now you determine the general solutions of 6 cos x minus 5 is equals to 4 divided by cos x. Of course, boys and girls, you need to prepare yourself in this type of equations. Of course, if you can get the first one like the one that we did earlier on, of course, that will be the bonus on your side. But you must expect something like the one that we are having here. 6 cos x minus 5 is equals to 4 divided by cos x. Of course, it's very important cos x must not be 0. Why is this cos x must not be 0? Because if you take 4 divided by 0, then this one will be undefined. Of course, it's a 6 marks question, and I give you 4 minutes to work out this problem, and of course, we will discuss with you immediately after 4 minutes. Right, thank you, boys and girls. Let us look at 10.3 now. The question was you determine the general solutions of 6 cos x minus 5 is equals to 4 divided by cos x. Right, what is it that you have in there? Right, now, okay, let us check first. Where are we going to start here? Where are we going to start solving this problem? Yes, of course. Now, first of all, we need to multiply everything here by what? By the lowest common denominator there. What is the lowest common denominator? Is cos. Then it means now we take the lowest common denominator, which is cos, then we multiply it each and every term here by LCD. Right, which is what? Which is cos x. Right, now, let us now take, if we take cos x multiplied by 6 cos x, what is the answer? Then the answer there will be 6 cos squared x. The answer then will be 6 cos squared x, and of course minus. We also take cos multiplied by minus 5. It will be minus 5 cos x. Good. And now is equals to, now 4 divided by cos x times cos x. Then the answer there will be 4. Right? Of course, it's very important. Multiply each and every term here by cos x. Okay, one can also decide to say, right, I can take 6 cos x minus 5, which is equals to 4 divided by cos x. Right, now I say this is the same as divided by 1. You treat 6 cos x minus 5 as if it's a one term. Of course, you need now to put it inside the brackets. It's very important. That's when now you can say, okay, now I take cos x, now I multiply 6 cos x minus 5 now with it. That's why at the end of the day, you will now be saying cos x multiplied by 6 cos x. Now you'll be having 6 cos squared x. And now you say cos x multiplied by minus 5. Now you'll be having minus 5 cos x. Right? It's very, very important. Make sure that you multiply each and every term here by cos. Right? Now we have 6 cos squared x minus 5 cos x is equals to 4. What is it that you're going to do now? Right, seemingly now it's like what I'm having here is like a quadratic equations, because now this is the exponent of 2, this is the exponent of 1, then this one here is the exponent of 0. Then it means now if this is a quadratic equation, then it means I have to move everything to one side. Then this one will be now 6 cos squared x minus 5 cos x, right? Now 4 here is positive. When I move it on the other side, we are going to have minus 4 there is equals to 0. Good. Now we have 6 cos squared x minus 5 cos x minus 4 is equals to 0. Then what is the next move from here? Yes, we need to check if we can factorize this one. It is very important, very, very important, right? Boys and girls, if we are finding it difficult to see, okay, this is cos here, the other one there is cos, you can just write with the pencil down. We say, okay, let now cos x be y or be whatever that you want. Can be k, can be w. Then, of course, now you say, okay, this one will be 6y squared minus 5y minus 4. At least now, once it's like this one, you'll have the picture of what is it that you must do on these questions here. Right, of course, now, let us now try to have factors of this problem here. Of course, now, the factors of 6, what are the factors of 6? Of course, the factors of 6 now we have 3 times 2, right? We have 3 times 2. Okay, that is cos x, that is cos x, right? What are the factors of 4? Yes, the factors of 4, then of course that is 2 as well as 2. Of course, that is very clear. Now, when you times 3 by 2, what is your answer there? The answer is 6. When you times 2 by 2, what is your answer there? Then the answer there is 4. Of course, when you minus the 2, then your difference then will be what? Your difference will be 2. Now, what is it that we are looking for? We are looking for 1. It's very important to make sure that each and every time you check what is your what? What is your middle term? Of course, now we have what? We have 6 now. We have 6 cos x multiplied by cos x on this side. And of course, the other one here then will be what? The other one, of course, will be, we have 4 on this side. And also we have what? We have 1. Of course, you still have to check 6 multiplied by 1. It's 6. And now 4 times 1, also 4. Then it means now the difference between the two, of course, is still what? Is still 2. Right now, what is it that now we are left with? Of course, now we are left with what? Now we are left with 3 as well as 2. Let me use y because now we're saving the space on this side. Thank you. Right now, and the other one is now to say we have 4 this one, and now we have 1. If we have 4, 3 times 4, you can see now it's going to be big. It's going to be 12. And now, but this side, if we are having what? If we are having 4 here and now 1 on this side, I think now this one will be much better now. It will be much better. Right. Now, boys and girls, now let us now move now to this one here. 6 cos x minus 4, this one. Then we have what? We have 3 cos x, and we also have what? 2 cos x, right? Now, it's equals to 0. Right, where do we put that one now? We have 3 cos x here, and now we have 2 cos x. Of course, now we take what? We take 4 this side, and now we take 1 on the other side. Right, now, the sign now will be what? The sign, of course, that will be minus as well as plus. That is a minus as well as plus. Right, of course, once you are at this stage now, you can now say 3 cos x minus 4 is equals to 0. Then now you transpose 4 on the other side. Now we have 3 now. Cos x is equals to 4. Then we divide it by 3 divided by 3. Then cos x is equals to what? 4 divided by what? 4 divided by 3. Then we say, or cos x, that is 2 here. 2 cos x is equals to transpose 1 on the other side. It becomes a negative 1. Then divided by 2, then cos x here is equals to 1 divided by 2 there. That is a negative 1, negative half, negative 1 divided by 2. All right, now, boys and girls, now when you look at this part here, it is that is why I said if you find it difficult to solve in terms of cos, on the side, try to say, okay, let cos x be y, let cos x be w. Then at least on that way, it will be easier for you to say, okay, if I factorize this one, let me check if the factors will be right. It's very important. One thing that will make your factors to be right is when you have the middle term right. Now, when you have your middle term right, then it means now your factors will be 100% correct together with the signs. Thank you very much. Right. Now, boys and girls, now let us look at this one. What was the question here? What was the question here? The question was we determine the general solutions. Right. Let me start with this one here. The reference angle here. What is the reference angle? That is the inverse of 4 divided by 3. Very interesting question here. What is 4 divided by 3? 4 divided by 3? Yeah, it says maths error. Let us look at it now. Shift, cos, then we have 4 divided by 3. 4 divided by 3. Now it says maths error. Why? Who can tell me why are we saying now we cannot have the reference angle for 4 divided by 3? Of course, you remember now the graph of cos. It is very important. That is why after this one now we are going to do the trig functions. The graph of cos, it starts from 1. Now it moves these directions and now it's also end here. Right. Now it means now it is between negative 1 as well as a positive 1. Immediately now, if you move above positive 1 or below negative 1, then your solutions then now will be, there will be no solutions for that one. Then it means for this side here, where cos x is equals to 4 divided by 3, there is no what? No solution. No. There is no solution for this part here. Right. Now, boys and girls, now let us now move to the next one on this side. Okay. Now, cos x is equals to minus 1 over 2 there. Right. Now, this one is very interesting now. At least now we'll have something to work on this side. Okay. Now we start with the reference angle first. Okay. That is cos, because it's negative here. Now, remember to make it what? To make it positive. That is the inverse of cos 1 divided by 2. Then we can check that one. That is shift, then cos, then 1 divided by 2 there. I think the answer then it says what? It says 60 degrees. Then we have 60 degrees on this side. Now we know that the reference angle for cos, for the inverse of cos 1 over 2 there at 60 degrees. Right. What is the next step now? Determine the general solutions. First of all, we need to start with the equation. Right. Now we solve for x now. X is equals to what? We check the ratio now. Is the ratio positive or negative? Of course it's negative. We check the quadrant in which cos is negative. That is the second quadrant. In the second quadrant we have 180 degrees. 180 degrees minus what? Minus 60 degrees. Is that correct? Or the other one, in which quadrant also is cos negative, that is the third quadrant. That quadrant then is x is equals to 180 degrees plus 60. Good. Now we are happy now with this one. Right. Now we need to answer the questions. At least now we have two quadrants where cos is what? Where cos is negative. Now when you determine the general solutions, remember now I said you check what is the period of cos. The period of cos here is what? The period of cos is 360. Then it means here now we are going to add what? We add k times 360. Then we add k times 360. There is the important part that you must not forget now is to write k's elements of the integers and also indicate that k is elements of the integers. Right. Now we can solve this one now to say, okay, what is 180 degrees minus 60? Now you check 180 degrees minus 60, then it says there the answer is 120 degrees plus k times 360. And now you go to the second one, say, okay, 180 degrees plus 60 degrees, that is 200 and what? 240 degrees plus k times 360 degrees there. Right now, this one here is a solution for this problem that we had earlier on, the one of 6 cos x minus 5 is equals to 4 divided by cos x, where cos x is not equals to, where cos x is not equals to 0. Boys and girls, like I said earlier on, if you know how to solve the trig equations, then for you to determine the general solutions, the only thing that you need to remember there is to have what? Is to have the period of cos. What is the period of cos? Is 360 degrees. On that one, you just add k times the period. What is the period? That will be k times 360 degrees. That is the period of sine as well as the period of the tangent. The two are very, very important. Right. Thank you, boys and girls. I think you have this 100% correct. Now we move to the next one. Right. What is it that we are having here? 9.3. It says determine the general solution now of sine x plus 2 cos squared x is equals to 1. That is now, remember the previous one, it was 6 marks. Now look at this one. That is November 2009. It was 7 marks. You see now the general solutions, it is very, very important. General solutions there, it is very, very important. Of course, boys and girls, now go through this question now. Sine x plus 2 cos squared x is equals to 1. Right. You solve this problem, I think it will take us through to the break. Now, immediately after break now, because you are going to have the 10 minutes break. And after break now, we are going to solve this one to see what is it that you have, and then you compare it with the solutions that I will be providing now after the break. Thank you very much. Right, welcome back, boys and girls. Remember now we're busy with the general solutions, November 2009 and 9.3. But boys and girls, the other thing which is very important when you solve this type of questions is you must know your identities. Now, you must know the double angle identity as well as the square identity. You remember now the one where we say sine squared theta plus cos squared theta is equals to 1, and the double angle for sine as well as the double angle for cos. Those two are very, very important. Right now, let us see what's going to happen with 9.3. Now, the question was determine the general solutions of sine x plus 2 cos squared x is equals to 1. Of course, let me write it down here. That is sine, of course, that is sine x. That is sine x. That is sine x plus 2 cos squared x is equals to 1. Right. Of course, boys and girls, when I look at this one, it's like we have something like a quadratic equation there. But remember now, I don't remember when we solve the quadratic equation, having x squared plus 2y plus 1 is equals to 0. Is it possible for you to factorize this problem here? No, it's not possible. It is only easy if you are only dealing with the x or you are dealing with the what? With the y. That is why it's very important each and every time when you solve the trig equation, then you see that you don't have the trig, you have sine as well as cos. Make sure that you try to make sure that it's either you have only sine or you have only cos. Right. One thing that will help us to do that is to check also to use the square identities as well as the double angles. Right now, we have sine here. Right, of course, there is nothing that we can do with sine. Is that correct? Yes. Then we leave sine x as it is. Now we move to say plus 2 here, multiply by cos squared x. Do you know something about this one here? Yes, you remember the square identity now where we have sine squared x plus cos squared x is equals to 1. Now, immediately from this one, you can now make the cos squared x the subject of the formula, right? Now, we'll have cos squared x is equals to what? That is 1. Now, when I move this on the other side, it's going to be 1 minus sine squared x. Then it means now, in place of cos, now we can replace it by what? By 1 minus sine squared x. Of course, now we open the brackets, we have 1 minus sine squared x now is equals to 1. Now look at this one now. Whatever now I have, this is sine x, this is sine squared x. Can you see now it's everything now in terms of sine? Then now it means it will be easier for me now to solve this problem here. That of course, let me simplify out. That is sine x plus 2 times 1 is 2. Then 2 multiplied by negative sine squared x, that will be minus 2 sine squared x, of course, is equals to 1. Right now, boys and girls, we can now rearrange this one because we can see now where it leads us now to the quadratic equation. Why am I saying this? Because now I'm looking at that exponent 2 there. Then it means now we have minus 2 sine squared x plus sine x. On this side, good. Of course, now this is a positive 2 right now. And now when you transpose 1 on this side, it's going to be what? It's going to be a negative 1. Is that correct? Yes. Now we say positive 2 minus 1. What is the answer there? The answer then will be positive 1 is equals to 0. Now we are happy. Now we have the equation now in the standard form. Then we can divide by the negative 1 divided by negative 1 divided by negative 1 divided by negative 1. Then at the end of the day, now we have a 2 sine squared x minus sine x minus 1 there is equals to 0. Right, now from here now, of course, like we did with the previous example, now we need to factorize this. We need to factorize this equation here. Of course, that will be 2 sine x. These are the factors of what? These are the factors of 2 sine squared x multiplied by sine x. 2 sine x multiplied by sine x, of course, will get 2 sine squared x. Now, what are the factors of 1? That is 1 multiplied by 1. Now, the sign here is a negative. You remember we only get the negative when we multiply negative 1 multiplied by positive, or positive multiplied by the negative. Now, what is the meaning of this one here? Then it means one bracket the sign is positive, the other one the sign is negative. Now, let us now check. Let us now check which one is the sign negative. Of course, the first bracket there, the sign will be positive, and now the second one, the sign will be a negative. Good. Now, basically, now from here, now we can now say therefore sine x is equals to, we move 1 on the other side, is going to be negative 1, then we divided by 2, right? Or then we have sine x is equals to the positive 1. Right, now, what is it that we are going to do now? We want to solve for x. Thereafter, now we know now we can now be able to determine the general solutions. Right, where do we start? The reference angle first. What do you know about the reference angle? Of course, the reference angle, it should be in the first quadrant, right? We have the inverse of sine 1 divided by 2. Why am I making this one positive? Because now x and y in the first quadrant, they are positive. Of course, now, what is the inverse of sine 0,5? Then, of course, now remember, now we say shift, and now you say sine, that is 1 divided by 2 there, and the answer is what? The answer is 30 degrees. Right, now we are happy, now we have the reference angle. Now it means once you have the reference angle, now we can now be able to solve for x. Right, now we say therefore x is equals to what? We go back, we check what is the sign of the ratio. It's negative. Now in which quadrant is sign in negative? Sign is negative in the third quadrant. Angle in the third quadrant, that will be, of course, 180 degrees plus. What is it that you're going to add there? We're going to add 30 degrees. Of course, we do the same on the other side. Or x is equals to, remember now, sine is negative in the third quadrant as well as the fourth quadrant. Right, now, what do you know about the angle in the fourth quadrant? That is what? 360 degrees minus what? Minus 30. Right, now, I'm happy I have the the third quadrant. This is the third quadrant. And also I have what? I have the fourth quadrant here. Right, now, what was the question? Determine the general solutions. Right, what do I know about the general solutions? Of course, from this equation, I add k times, what is the period of sine? The period of sine is 360 degrees. And also, I do the same. I add k times 360 degrees. Of course, we mustn't forget to say, of course, k is an element of what? K is elements of the integers. K is elements of integers, and also k is elements of the integers also on this side. Right, now, from here now you can simplify to say 180 degrees plus 30, that will be 210 degrees plus k times 360. Good. And also on this side, you do the same. 360 degrees minus 30, that will be 330 degrees plus k times 360 degrees. Good. Now we have now two solutions now for sine x is equals to a negative 1 divided by 2. Good. Now, boys and girls, now we are done with the first part now. Remember now the other one, when you factorize this one, you got now sine x minus 1. Then you say, therefore, here sine x is equals to what? Sine x is equals to the positive 1. Therefore, also on this one also, we can have the reference angle. Is that correct? We can also have the reference angle here. What is the reference angle? Of course, the reference angle here will be the inverse of sine of a positive 1. Now we can now check this one to say, okay, we have shifted there, sine of positive 1. Then what is the answer there? The answer there is 90 degrees. Can you see now? Of course, we now have 90 degrees. Of course, now the ratio there is positive. Now, when you solve for x, now you say, therefore, x is equals to what? X is equals to 90 degrees. Why 90? Because sine is positive in the first quadrant. Is that correct? And also sine is negative where? Sine is positive in the first quadrant, also in the second quadrant. Right? Now, what do you know about the angle in the second quadrant? That is 180 degrees minus. It means when we say 180 degrees minus 90, what do we get? We are going to get a 90 degrees. It means for this side, I can now say, therefore, x is equals to 90 degrees plus k times 360 degrees, where k is element of what? Where k is element of the integer. It means from these questions, you have three solutions, 1, 2, as well as 3. 210 plus k times 360, and the other one is 330 plus k times 360. Then the last one, of course, it's x is equals to 90 degrees plus k times 360. Boys and girls, it's very important, especially if we can get this part from here now. Once you are here, then you know. That is the basic one. Once you can identify the ratio, then to take it there to solve the equations and then find the general solutions, then of course it will of course be easier for you. Okay, I think you are following well. Now let us now try to change now to see what. Now we have applied the square identity on this one, right? Now let us now see what is it that will happen now when we apply the double angle. Okay, right, we have February 2012 now. We have February 2012. Now we have this question here. It says now, determine the general solutions now of the equation sin x is equals to cos 2x minus 1. That 2, then it means what? It means a double angle, right? That is a 6 marks question, boys and girls. I believe now you are following well. For these 6 marks, we can solve this problem within 4 minutes. Then immediately after 4 minutes, then we are going to discuss this problem with you. Thank you very much. Right, thank you very much, boys and girls. Right, let us try to solve this problem. Sin x is equals to cos 2x minus 1. Of course, now you can see you have sine as well as what? Sine as well as cos. Remember now it is easier for you only if you work with sine or cos only, right? Now, then like we did previously with the other examples, right? On this one, we have sine x. There is nothing we can do with sine x. Now we leave sine x as it is. Right now, when you go on the other side, we have cos 2x, right? Immediately now, when I see this one, right, what do you remember now? I remember the double angle. But now, this one is a double angle for cos. Now, remember now, we say cos of 2a. We say cos 2a is equals to what? Is equals to cos squared a minus what? Minus sine squared a, right? Cos 2a is equals to cos squared a minus sine squared a, right? And also, one can also say, we also have what? Cos 2a is equals to 2 cos squared a minus 1. That is the second one. And now the third one here is cos 2a is equals to 1 minus 2 sine squared a. You need to remember the two. That is why it's very important to make sure that once you're solving this type of the equations, now make sure that your information sheet is next to you so that at least you can be able now to choose the correct formula. Right. Now, cos 2x here, now because I want only the sine, then it means I'm not going to use the first one. Why? Because I have cos as well as what? Cos as well as sine. Right now, when I look at the second one, also I'm not going to use the second one. Why? Because that is 2 cos. There is still cos in that one. Of course, if you use this one, remember now, you still have to go on another way now to change the cos. But of course, I can use the third one. Why? Because it's only sine there. Then it means now this one I can say is the same as 1 minus 2 sine squared x minus 1. Then it means in this case now I'm happy now because I can see now everything now is in terms of what? Everything now is in terms of the sine. Good. Now from here now I can move this one to the other side. Now we say this is going to be positive 2 sine squared x and then plus sine x here. Right, 1 minus 1, it's 0. Therefore, now the other side there is, it's 0. 2 sine squared x plus 2 sine x is equals to 0. Then now, this is a quadratic equation, but now with two terms, how do we solve this one? Then you take out the common factor. What is a common factor? It's a sine x, right? Sine x. Now we say, okay, we are left with what? We are left with sine x plus what? Plus 1 is equals to 0. Right, of course, boys and girls, you now say, therefore, here, you say, okay, sine x is equals to 0, and then, or sine x is equals to negative 1 divided by 2. You remember now in the previous example, now we have the solutions for sine x is equals to negative 1 over 2. Of course, you need to have the reference angle, then you identify in which quadrant it's sine negative, and now you solve the problem. Of course, sine is negative in which quadrant? The third and the fourth. Therefore, the answer that I think you have here, then the x should be what? It should be the inverse of 1 over 2, if I remember, is still 30, right? Yes, you have 30 earlier on. That is sine 1 divided by 2. 1 divided by 2 here. Then your answer there is, it's 30. Then it means your final solutions is x is equals to 210 plus k times 360 degrees, where k is elements of the integers. Or the other one there is what? X is equals to what? X is equals to 330 degrees plus k times 306. These are your final answers, right? What about this one on this side? Sine x is equals to 0, right? Of course, the reference angle, of course, that will be the inverse of 0 degrees. What is the inverse of 0 degrees? Yes, it's 0, nay. That is 0, right? Of course, that is 0 here. Then the inverse of sine 0, that is a 0 degrees. It means what we have here, it's 0. Now, in which quadrant is sine positive? That is the first. Then it means x is equals to what? X is equals to 0 plus k times 360 degrees. Of course, the answer can just be there, 360 degrees there, where k is elements of the integers. Or the other one, it is also what? In the second quadrant, that is 180 degrees minus 0. 180 degrees minus 0 plus k times 360 degrees. Then your answer there is 180 degrees plus k times 360 degrees. Of course, you mustn't forget to write k is the element of the integers. Boys and girls, I think plus or minus now I can see now you are fine with this one problems here of determining the general solutions. Of course, I think we can do 10.4 together so that at least we can now be able now to move to the functions now. Okay, right now, let us now try to go step by step on this one, 10.4. 10.4, it says also determine the general solutions of sine x plus cos 2x minus cos x is equals to 0. Right, how do I solve this one? Of course, let me write it down. That is a sine squared x plus cos 2x minus cos x is equals to 0. Good. Now we are happy. Look, we have sine squared x plus cos 2x minus cos x is equals to 0. If you want to solve these equations, we must make sure that we have everything in terms of sine or in terms of cos. But what I see here, there is nothing that we can do with cos. Then I must make sure that I change these two sine squared x together with cos squared x to what? To cos, right? Now, there are many ways that we can do to solve this problem. But now let me keep this one the way it is, that is a sine squared x plus. If I keep this one the way it is, then it means when it comes to this side of cos squared cos 2a, then it means we must choose the first one where we have what? Where we have cos 2x is equals to cos squared x minus sine squared x, then minus cos x is equals to 0. Right, now look at this one now. Now we can now say, okay, sine x minus sine squared x minus sine squared x. What is the answer there? It's a 0. Therefore, now we have what? We have cos squared x minus cos x is equals to 0. Then immediately from here, now we can say what? Take out a common factor. What is the common factor? The common factor there is cos x. Now we are left with what? Cos x minus 1, then is equals to 0. Then now look, you see now, therefore here, cos x is equals to 0 or cos x is equals to the positive 1. Right, you know from here what is it that you must do, right? Then you determine the reference angle. What you see, what is the reference angle? Of course, that is the inverse of 0 degrees. Remember, we have the one of sine was 0. Now let us check the one of cos here. It must be positive 1, right? Now it must be what? It must be 90 degrees. It must be 90 degrees. That is shift the inverse of cos 0 degrees there. That is 90 degrees. Good. Then therefore the reference angle there, it's 90. Right? Why do we say 90? Good people, you know, when you come to this type of questions, you need to remember the trig functions. The standard one is very, very important because you know that the graph of cos start on this side here. It starts from positive 1 now to add 0 here. That is 90. But what about sine? Sine start here. Now it goes at the turning point there. It's 90, where y now will be what? Will be a positive 1. Right, now from here, boys and girls, you know now we can now say therefore x is equals to what? Now you check it is positive, therefore cos is positive in the first quadrant, x is 90 degrees plus k times 360, then k is elements of the integers there, and also cos is also positive in which quadrant? Of course in the fourth quadrant, therefore that one we now say x is equals to 360 degrees minus 90 plus k times 360. Of course, we are going to have 270 degrees plus k times 360. Right. What about this side here? Also, the reference angle is very, very important here. And now the inverse of positive 1. And now you check what is the inverse of cos positive 1. That is a shift cos, then positive 1 there. The answer then is what? The answer then is it's 0. right? That is a 0 degrees. From this one, I can just read it here. If cos is 1 here, if the ratio is 1, then the angle there is what? The angle there is, it is 0 on this side. Thank you very much. Right, then boys and girls, from here now you say, okay, the ratio positive, in which quadrant is cos positive? Of course, you can just read it here. Cos is positive here, as well as on this one here. Then your answer then will be x is what? X is 0, of course, plus k times 360 degrees. And the other one there, x will then be what? X will then be 360 degrees plus k times 360 degrees. You remember how the graphs move now. From this part it moves then at 360. Then we also have what? We also have the positive 1. Right, boys and girls, I think now you are happy with this one. It is very important to make sure that you have these questions right. It is very, very important. Right, boys and girls, sometimes, especially when we prove the identities, when you prove the identities, when you look at 8.2, they say consider the expression. Here the expression is given. Then we are fine with that. Now we move now to 8.2.1. Now they say prove that the identity 1 minus cos 2x minus sin x divided by sin 2x minus cos x is equals to tan x, right? Of course, I know you are not going to struggle to prove that one, but what's important now is 8.2.2. What's important now is 8.2.2. Now it says now the above expression is undefined if sin 2x minus cos x is equals to 0. Solve this equation in the interval 0 to 360. Right? It's very important. Now basically it means, remember now this one, at least now we are told that to say if sin 2x minus cos x is equals to 0. Now sometimes you get something like to say if the expression is undefined, determine the value of x. Now they are not going to tell you that this is equals to 0. For us to make this expression undefined, then remember now the denominator must be what? The denominator must be 0. Of course, this is the last one that we are going to do now under the tricky equations, right? It's a 4 marks question. I think we can take 3 minutes. Then immediately after that, now we are going to discuss it together. 8.2.2, the above expressions undefined if sin 2x minus cos x is equals to 0. Now solve this equation in the interval 0 degrees. It's less than or equals to x less than 360. 3 minutes, then we discuss the problem. Thank you very much. Boys and girls, now you have the answer there. It means now this one is exactly the way we have solved the problem. But now before we look at this one, boys and girls, let us look at this one. We have the restrictions on the identities and trigonometric equations. It's very important now. When are you going to apply that restrictions? Now it is important now to realize that the denominator of a fraction can never be equals to 0. That part is very, very important, right? Now, from the identities learned in grade 11, it is clear that tan theta is equals to sin theta divided by cos theta. Now, then it means tan theta is undefined when cos theta is equals to 0. Now, you remember that's why now we have that the asymptotes. Now, in other words, when theta is plus or minus 90 degrees plus 360, times k, and k is elements of the integers. Now, it means now the tan then will be undefined on this interval here. This is the reason for the asymptotes on the tan graph. If you divide by the 0, then that identity will be undefined. That is why it is very important to remember that one. Then it means now this identity as well, this one also will be undefined if sin 2x, minus cos x is equals to 0. Right now, if you solve this one, then you know this is 2 sin x times cos x. Of course, the double angle for cos is not easy, straightforward. You don't choose like you did with cos, right? Minus cos x there is equals to 0. Then from here you are fine. What is it that you're going to do? You take a cos as a common factor, right? Then you have cos x out. Then now you are left with 2 sin x minus 1, then is equals to 0. And once you are here now, cos x is equals to 0, or sin x is equals to 1 divided by 2. But now here they were specific to say between the two intervals, right? This one you don't need to determine the general solutions. You just solve this one to say, okay, the reference angle there, that is the inverse of cos 0. You said the answer there is what? It's a 90. Right? Of course, not only 90, also in which quadrant is cos positive? That is also in x is equals to 90 degrees, or x is equals to what? X is equals to 360 degrees minus 90, which is equals to 270 degrees. These are the phase 2. And the other one also is on this side. The reference angle here, that is the inverse of sine 1 over 2 there. What is the inverse of sine 1 over 2? That is 30 degrees, right? That is 30 degrees. Good. Now from this one, now you say x is equals to 30 degrees. Why 30 degrees? Because sine is positive in the first quadrant. Or x is equals to what? 180 degrees minus 30. Then which of course is going to be what? Which of course is going to be 150. These are the answers within this interval. It means that is 30, 90, 150 together with 270. These values of x will make this identity to be undefined. Right. Thank you very much. Now, good people, now let us now move to this one. I think now you have the equations. Remember, once you master the part of the equation, then it will be easier for you now to determine the general solutions, right? Remember, you solve the equations, you separated the two, the ratio one side, then trig function on the other side. Then from that one, the reference angle, remember, always in the first quadrant, right? Then from that one, then you can solve the theta, or you can solve for the value of x, right? Thank you very much. I think now for the trig equations, now the straightforward, now we are covered with this one. But sometimes you'll find that under the trig functions now you still have to solve the trig equations there, right? Let us take one or two under that one. Right, let me now look at November 2008. Right, boys and girls, you still remember well the trig function, sine as well as cos as well as the tangent. You still remember the three very well. Now, quickly before you solve the problem, right, you need to have this in your mind. Remember, it's 0 to 360. Now, how does the graph of sine looks like? Of course, the graph of sine, it is this one here. That is the sine graph, right? Now, what is this value here? That is 90 degrees. What is this value here? That is 180. What is this value here? That is 270. And this is 360. Right. Now, what about cos? What about cos? Now, the graph of cos also, you need to remember the two. Now, the cos graph now start from this one here. Now, it moves this direction. And now, it's end here, right? Now, the question now also be, what are these values here? It's very important here. This is 90 degrees. What about this one here? It's 180. What about this one here? 270. And of course, the last one there will be 360. Of course, the value of x here will be 0 degrees, so that our y then can be a positive 1. Right. Now, boys and girls, the two here are very, very important. But now, what is it that is important? This is y is equals to sine x or sine theta. This is y is equals to sine x. And now this is y is equals to cos x, right? Now, what about the one for tangent? Of course, remember now we have this one here. Of course, now what's important is these two here. That is 90 as well as what? As well as 270. Then that's where now you have the asymptotes. Right, what is the shape now? This is the shape. Of course, now this is the shape as well. You have this one. And of course, from this one now we are going to have this one here, that is to 360. Boys and girls, what is this value here? It is 180. This one here is 360. Remember this graph. Why? Because it will give you the standard position for the graphs. Okay, right. Boys and girls, now let us look at November 2008. I know you know how to sketch the functions. 8.2, you are happy with it. I know you know how to sketch the functions. But now, what's important now, I want us to look at 8.1. I want us to look at 8.1. How are we going to solve the question 8.1? How are we going to solve this question 8.1? It's very, very important, right? Boys and girls, it's an 8 marks question, right? It's 8 marks questions. Let me give you, of course, if you can have the four steps correct, then you will be able now to see, now I'm able now to solve the problem, right? Okay, right. Now, let us quickly look at this one together now because time is not on our side. Of course, solve for x if f at x, right, is equals to g at x. Okay, now, what is f at x? It's a cos, right? It's a cos 3x. And then what is g at x? It is a sine x. Good. Now, from here now, remember on the previous examples that we did there, we said make sure that everything that you are working with is either in terms of sine or in terms of cos, right? What is it that you are going to do on this one? You have cos 3x is equals to sine x. You remember when you are solving the exponential equations, when you have 2 to the power of x is equals to 2 squared, now you say, okay, if the bases are the same, we then equate the exponent to say, therefore, x is equals to 2. Right now, we are going to solve this problem exactly the same way, but now it only works if we have cos on the left-hand side as well as cos on the right-hand side, or we have sine on the left-hand side as well as sine on the right-hand side, right? But now, at the moment, when I look at the 2, I still have cos as well as what? As well as sine, right? What is it that we must do now? We can now apply the co-functions to say, okay, cos of 3x here is equals to, we know that sine x is still the same as what? Cos of what? 90 degrees minus x. Cos of 90 degrees minus x is exactly the same as sine x. Therefore, now we can now say, okay, let us now say sine x is the same as what? Is the same as cos 90 degrees minus x. Can you see now? Now we are happy. Now we have cos x. We have cos, Then now we can say, okay, now we have the same trick now. This can now be, say, 3x is equals to 90 minus x, right? But now we need to check now. Let us look at this one here. Now, cos of 3x is equals to positive sine x. Then it means now we take this one and say is our ratio. Then we say it is positive. Now we say, in which quadrant is cos positive? That is the first quadrant, right? That is the first quadrant here. Now, of course, now if I determine the general solution, now we say plus k times 360. Of course, where k is element of the integers. Right, I take this on the other side. That will be 4x there is equals to 90 degrees plus k times 360. Of course, now I divide by 4, everything divided by 4 there. Then x is equals to, what is 90 divided by 4? 90 divided by 4, it's 22,5 degrees. And also 360, also you must divide it by 4. That is 90. That is k times 90. Of course, that is the first one. The second one, where cos is positive, of course, it will be where? It will be in the fourth quadrant where we have 3x is equals to 360 degrees minus what? Minus 90 minus x, right? And then plus k times 360 degrees, where k is element of the integers, right? Now, when I simplify this one, that is 360 degrees minus 90 degrees plus x plus k times 360. Of course, from here now, we can say 360 minus 90, that will be 270. Now we take x on the other side. Now that will be plus x. Then it means we have what? We have 2x, because 3x minus x, then the answer then will be 2x, and now plus k times 360. Right, divide by 2, divided by 2, divide by 2, then x is equals to 270 divided by 2 there. Then the answer is 135 degrees plus 360 divided by 2, of course, that is 180. Good. Now, what is it that you must do now? Remember the question now said, solve for x if f at x is equals to g at x, right? Now, of course, now this is the general one now. The interval now is given now. We must work on this interval, minus 92, 180. Right, now how do we get that one? Of course, now because we have k times 90. For this one now, we can now say, okay, let us substitute k with what? K with -1, and now with 0 there, as well as what? As well as 1. Now, let us see also as well as 2. Now, the question will be, why are you choosing these numbers, -1, 0, 1, and 2? Because I see that when I take -1, replace it with k, then it means we are going to have -1 times 90. That is what? That is -90. It means with this one, we are covered. We have -90. And also, when I take 2, multiply by 90, what is the answer? 2 multiplied by 90 is 180. And also then it means I have covered this interval, minus 92, 180. Right, now from here now we say, okay, right now this one, -1 times 90 then is what? It's a -90, right? And now plus 22,5, then the answer there is minus 67,5. Now if k is 0, then we have 22,5, right? We have 22,5. If k is 1, is 1 times 90, that will be 90 plus 22,5. Then we have what? We have 112,5. And of course, if k is 2, then that is 2 multiplied by 90. That is 180. 180 plus 22,5. Of course, we can see now this one now, it is outside there. It is outside the interval, right? Of course, now, for this one, we are happy, but immediately now I can just make a conclusion to say, okay, this one is not part of the solutions there. Why? Because remember now we are working within the interval, minus 92, 180. Good. Now, the first one there, the solutions there are x is element of what? X is element of minus 67,5, and then also 22,5 and 112,5. This one is between minus 90 as well as 180. Right. What about this one here? We exactly do the same thing on this one. That is what? Minus 1 and also 0, 1 as well as 2. Right. Now, immediately when I substitute this here, then we're going to have minus 180. Right. Plus 135. What is the answer there? The answer is 150, 157. Okay, no. Minus 180 plus 135. What is the answer? Minus 45. Yes, that is minus 45. Minus 45. Let me write it here. And now for 0, we have 135 because k is 0. Everything there is 0. But if it's 1, then immediately I can see this one is going to be more than 180 because it's going to be 180 degrees plus 135. Then, of course, the answer there is 315. And this one now is more than worse now because that is 180 degrees. 180 degrees times 2 is 36. Now I add again 135. Then it's 495. Then it means this one now, the solutions then will be, the solution now will be minus 45 as well as 130, 135. Right, these are now the solutions for this problem here. Remember, it's very important. You'll get this type of questions, especially when they ask you to determine the values of x for which f of x is equals to g at x. It is very, very important. But you see, once you have the general solutions, then it is easy for you to check those because you just substitute the k with this value. So k minus 1, because if this one was minus 180, then of course I would have started from what? From negative from -2. But now because it's 90, then I started with what? With the -1, so that I know that I can work within that interval. Boys and girls, the trig ratio, the trig equations as well as trig functions, they are very, very important, especially when you solve when you solve for x or for theta. But this type of the equation under functions, you only get them when they say f at x is equal to g at x, or when the question says now where f intersect with g. Now you know that where the two graphs intersect each other, then at that point the graphs are the same. Now we have more or less the same question here. Calculate the point of the intersections of the graph f and g. Intersection, where the two graphs intersect, then we know that at that point, what is it that is going to happen there? Of course, the two graphs are equal. Okay, boys and girls, I think also this one. Let us look at it quickly now. We have f at x is equals to 1 plus sine x, and gx is equals to cos 2x. It's not difficult, more or less the same, the one that we did. It's a 7 marks question. It's a 7 marks questions. Maybe if I can just see the first 4 steps, if I can just see the first 4 steps, then I will be happy. Then I can just say that one can do it within 3 minutes, right? Yeah, let me just give you 3 minutes to solve this one. Only the first 4 steps, then I will be happy. Then at least from that one, now I would say now you have an idea of what you must do. Okay, thank you very much, boys and girls. Now, let us look at the first 4 steps. Then from that one, just I know now you know how to solve the equation now. If the two graphs intersect each other, calculate the point of intersections of the graph f and g within this interval. Of course, it means now f at x now is equals to g at x, right? Now, just substitute to say this one will be 1 plus sine x is equals to cos 2x. Is that correct? Yes. Now look now. What you have now, of course, this one now we are happy about it because at least we know that this one, if I write everything in terms of sine, this will be 1 minus 2 sine squared x. And what about this one? It's a 1 plus sine x. From here now, this is 2 sine squared x and plus sine x. Now, then this is a 1. When I take that, it's a minus 1 is equals to 0. Now, it means now you have 2 sine squared x plus sine x now is equals to 0. Can you see now? It's exactly more or less like the example that we did earlier on. If you can just understand the intersection between the two, then everything will be fine for you under the trig equations. Boys and girls, you must master, you must know how to determine the trig functions. To sketch that function is very important. And now solving the equations. Determining the general solutions, of course, is not difficult. If you can have your equation, then the general solutions, now you just check the period of sine, the period of the tangent, the period of cos. Then you'll have the general solutions. Thank you very much.